Perhaps the best way to learn how to use ggplot2 is to roll up your sleeves and to try to plot some charts yourself. You'll have taken a look at the slides, perhaps you've read the report that contains a bunch of examples. Here I'm going to show you how you would produce a Gapminder style chart. Gapminder is a package that contains a lot of socio-economic data, and it's become very popular over the last few years. We're going to recreate one of the famous charts, the Wealth and Health of Nations charts. We do so in R. We need to first start by loading a few packages. In particular, we will need the following packages. We load the tidyverse, which will help us manipulate the data. We load ggplot2, which actually is required to produce a ggplot chart. The data resides in a package called DS Labs. I'm going to load the Wes Anderson package because it provides us with nice color palettes, and I'd like to modify the default color palette that comes with ggplot2. And finally, we will load the ggrepel package because we're going to want to add some labels to each of the data points. But if we're not careful, because there's going to be a lot of countries, all of the texts will overlap. So the ggrepel package makes it so that the text doesn't cover the data. At least it minimizes the amount of... The data set itself is found in the Gapminder object. It has been loaded. Let's see what the help file tells us about this. So we have a description. It's the health and income outcomes for 180 some countries for a period of roughly 55 years. Let's look at some of the variables. We have the country, we have the year, we have infant mortality, given in infant deaths per 1,000, life expectancy, fertility, population, the GDP, given by the World Bank, the continent on which the country is found, and the region in which the country is found. A little summary here to get a sense of the ranges for the variables. We'll see. So there's a bunch of countries that have been listed. We have 57 observations for each country apparently. So 57 years. Minimum year is 1960, maximum year is 2016. Yeah, these are the 57 years. We have rates for each of the observations. It turns out we have a fair amount of missing values. So we don't have infant mortality for all the countries for all the years. Same thing with fertility, although life expectancy we do have data for everything. Population, we're missing some, 185. So it looks as though we're missing potentially 1 year's worth of data. The GDP, we're missing a number of observations, but we do have continental membership and regional memberships for all of the countries. Let's take a little look at the structure, perhaps get more information here. I'm seeing there's about 10,000 observations in total, 9 variables. If I have 57 years worth of data, if I divide 10,545 by 57, I should get a number of countries. Yeah, I have 185 countries in total. Okay, so this at least makes some sense. The country is a factor, the year is an integer. Infant mortality, life expectancy, fertility, population, GDP, these are all numerics. And the continental membership and the regional membership, these are factors, categorical variables. We are going to pick a year for plotting. Here I'll pick 2009. Perhaps you'd like to say, oh, I could pick 2016. Eventually, if you play with the data, what you're going to find is that a lot of the missing values are for 2016. So I'm going to pick a year for which we have a fair amount of information. So the year will be 2009. You have the choice with this code to change the year, and you'll be able to produce a chart as well. And I'm going to do so by basically using this variable here in various steps. So for instance, the chart title will be dependent on the year. Let's see what it looks like if I just call it. I'm getting Health and Wealth of Nations /N Gapminder 2009. So the 2009 would change if I use a different year. You might wonder what this /N does. When the time comes to publish my chart or to print it, I'd like the Gapminder 2009 bit to show up on a different line. So /N tells R to place what comes after on a different line. It's basically like a new line command. I'm going to start by sorting the countries by inverse population. This is going to come in handy later when I want to select only some of the countries to have a text label. Now, you don't necessarily have to do this part if you just want to produce the chart, but given what I want to do down the road, that's going to be helpful. So what's happening here is I'm keeping the Gapminder data set, but I'm going to have a new order. The order being that for every year, the population will be decreasing. So what this is going to do as a step, it's going to sort by year by inverse population. It does so on the rows, and all the columns are being outputted. All right, so let's run that. In my chart, as I've mentioned, I won't want to have every country labeled with a name. I'm going to pick a number of countries to label, 20. Eventually, I'm going to write code where only 20 countries are selected randomly to have their names on the observation. We'll start by only keeping the observations that have the year that we want to plot, which is to say 2009. So I'm going to use the tidyverse and the pipeline operator. I want to take data from the Gapminder data set, but I want to filter it so that the only year I retain is the year variable that I've chosen, 2009. This year here is the name of a variable. It has to be spelled exactly as it appears in the data set, right here. And this YR piece of code, that's a variable that I've declared before. So this first chunk here would only keep data for 2009. Let me see what happens when I highlight it and I run it. I'm getting a filtered data set, and you see I only have 185 observations. So only the observations for 2009 have been retained here. How do I know that for a fact? Let me take a quick look at the summary. And I'm going to get, for the year, everything is 2009. Now, for the chart that I'm interested in, I want the population and the GDP per capita, not just the GDP itself, right? Bigger countries tend to have bigger GDPs. That is not unexpected. I'm interested in the GDP per capita. So I have to create new variables. I'm going to use for the population a population in millions so that the numbers aren't too big on the axis, but that one is less necessary. So I create two new variables, pop_m and GDPPC. Pop_m will be the actual population divided by a million, and GDPPC will be the GDP divided by the population. So mutate will actually be applied to the filtered Gapminder data set, and basically it's going to create two new variables. So I'm going to run the entire pipeline. So now I have a new filter.gapminder. You see here we have 185 observations of 11 variables. So we've created new variables. And again, for the sake of being able to only label some of the observations, I don't want to have 185 labels. My plot is going to be too busy. The next little bit of code that I'm going to show you is going to allow me to decide which of the countries get labeled. And I'd like to give larger countries a higher chance of being labeled. So I'm going to create weights, and the weights are going to be proportional to the size. So what I'm doing here is I'm taking the population of a specific country and I'm dividing it by the entire sum of all the populations, the population of the planet in a sense in 2009. Let's see what happens when I run this line. So now I've created a vector, so I get 185 observations. Yeah, these are all pretty small numbers. Okay, that sort of makes sense. And to show you that these are probabilities, I'm going to add up all the weights, and you will see that they add up to 1. Sure enough. So each of these small numbers here represents the probability that the corresponding country will be selected. And the numbers early on in the vector are larger than the numbers at the bottom, right? We have 10 to the minus 6 here, which is pretty small, because we've sorted the countries in order of population and because the weights are proportional to the population size. So that first weight here corresponds to China, the second weight corresponds to India, and so forth. Once this is done, we are going to sample which countries actually will be given labels. Let me just compute this sample here. This is the list of countries which will end up having names associated to their data points. Only 20 of them. And you notice that the first country, second country, third, fourth, fifth, sixth, seventh, eighth. So the larger countries will be there, but eventually some of the smaller countries will also have names. This next piece of code here basically just writes the name of the country out to be displayed if it's going to be one of the countries to be displayed, or it leaves an empty string if it's one of the countries that was not selected to be displayed. Well, the specifics of this don't really matter here, but just so you know, we now have a new variable. So now we've prepared our data set. We are going to be working with the filter.gapminder data set. It has 185 observations, one for each country, 12 variables because we've created 3 new variables: population in millions, the GDP per capita, and this country display, which will decide which countries get labels and which don't. So let's start with our coding. One of the nice things about ggplot2 is that it is compatible with the tidyverse. So I can use the pipeline operator to produce my charts in successive steps. So this is telling you what data set I'm going to be plotting, and I'm going to feed that into ggplot. Now remember, in ggplot you're supposed to have the name of a data set, but this pipeline here is basically telling ggplot that the data set to use, the thing that's missing here, data set, is actually the thing that shows up on the left. So we're creating a chart which will have the following aesthetic mappings. The GDP per capita is mapped to the horizontal axis. The life expectancy is mapped to the vertical axis, and the population in millions will be mapped to the size of the bubbles. So this is what the aesthetic mapping is. We need to specify what geometry we want, and we'll pick the geometry of a bubble chart, a scatter plot. So geom_point. I'm going to add a new aesthetic here. I'd like the continent to be mapped to the fill. So the color of the bubble will depend on continental membership. This PCH equals 21 bit tells you that you want to use a specific shape. 21 is the shape that corresponds to fillable circles. So it goes from 1 to about 25, and the first 20 shapes you don't have any control over the fill. 21, 22, 23, 24, and I think 25 as well allow you to modify the color inside the marker. So let's see what happens if we plot. Okay, so some rows aren't going to be plotted because we're missing values. That happens. We have 181 and we get this chart here. Alright, that's not bad. That's sort of interesting to see. We do not have the country names because we haven't mapped the country names to anything. Now, as I told you, I'm not particularly fond of the colors. I don't like the default ggplot colors. We're going to make a change here. We are going to add a new color scheme. So we're adding a new scale. Scale is going to work with the fill values. And so what we want is for the color values to come from the Wes Anderson palette named Darjeeling 1. And we want only 5 colors to be chosen because we have 5 continents. So let's see what that actually looks like. I'm going to run, and what's going to happen is I'm just rerunning the chart again. And so you see here I have the same chart, except using different colors. The GDP per capita goes from about, well, at least 0 to 50,000 for some of the wealthier countries. Typically, this is shown in a logarithmic scale. So let me make this modification. We're going to use a logarithmic scale for the x-axis. Notice here I've added the plus, right? Every time you add a new plot element, you need to add the plus. So let's try this again. Okay, so now the data points are a little better spread, a little better spaced out. About the actual labels themselves, as I've told you, we only want some of the countries to be added. Just like to know which countries they are. It looks as though it's not unlikely that the bigger bubbles, which are related to the population, would be China and India. Can we find out exactly which ones are which? So this piece of text here is going to add a geometry which is labeled for the points, but it's going to use the repel option. So this comes from the ggplot2 package, and what we want for aesthetic mapping is that the country display variable will be mapped to the label, and the size of the label, the size of the font that we use, is going to be proportional to the square root of the population divided by pi. So roughly speaking, what we want is the size of the text to indicate how populous the country is. I'm going to use a bunch of other options. Alpha represents the transparency, what kind of font I want to use bold, and this min.segment.length makes it so that you don't have lines that are too big or too small, and I won't need to see the legend. But remember, so I've added the plus to get all this to make sense. If I put all this together, I'll get the following thing. And I'm seeing, sure enough, here's China, little line, India is here, Pakistan is here. I'm getting some of the countries. Not all of them have been added to the chart. It'd be very difficult to read, but enough of them. You get a bit of a sense. Let's clean this up a little bit. We're going to add a title, some labels for the axes, and get a slightly easier theme to read for printing. And we're going to use a different theme to try to get a nice font for the title. Let's run all this. Alright, so this is starting to be a fairly decent little map. Now you might look at this and say, well, I'm not too keen on the life expectancy limits. I'd like to modify those a little bit. So I'm getting a little bit of space above and below. That's good. And finally, I'm going to add something about the size scaling. So I don't really like these breakdowns for this. The size, I would like them to perhaps be more logarithmic in nature. So I'm going to add a little. So now my bubbles are much bigger, right? And it's clear to see which countries are big and which countries are small. There's a lot of overlap. At the end of this, I'm going to give you a full screen version as opposed to a compressed version. Is there a few other things I might want to do? Well, I might want to have different guidelines. These are the lines that sort of cross around. Let me add a few other options. Something about the labels as well. I don't like this continent label, this population M label. I'd like them to be a little bit more, and I'm going to get rid of the gray background. Okay, so now let me run all of these things together. I actually get a pretty decent little chart and get a version which is much more spread out. So as you can see, it's fairly easy to make appealing looking charts with ggplot2.